All right, we are in Windows World with a new face. Who are you?
I'm Chittur Subbaraman. I'm a member of the kernel team.
Excellent.
And I've been here for 10 years.
Nice.
I've been in the kernel team for over 4 years, and in Windows for about 10 years.
Excellent.
And I work in the service controller and tasks area. So in general, the background processes for Windows.
Excellent. And there's a fair number of those on any given system.
That's right. So the services and tasks historically have been have a model in Windows whereby they start up at boot, wait for some rare events, and then shut down when the machine shuts down. So that has been historically the sort of model we have for services in Windows. And what happened is that in XP, the set of services was not that large. It was around 50 always running services, and they were fairly lightweight, and people didn't notice too much of problems with them and things like that.
Yeah.
And then what happened was that you had the blaster virus somewhere after XP was released. After it was back in 2003, if I remember. XP was released in 2001. And then what happened was that then the focus sort of shifted to these things which run all the time. The user doesn't typically notice them. They do some task on behalf of the user.
Sure.
But the user is kind of unaware of most of the regular users. But they have a huge penalty if they don't work properly. And when I say work properly, they should ideally work like the operating system itself. They're actually extensions of the operating system. They should work like as good as the OS itself. And if you introduce a bad service to Windows or a bad component which runs all the time, the user experience is terrible. And it can range from enormous cost in terms of dollars, productivity loss, and if a virus takes over your machine because of a flaw in a service, then the cost is very, very high. And the performance cost is another one that people complain a lot. Why is my machine so slow? Why is my logon taking forever? Why is my machine is always in, I am booting, please wait, kind of thing, right? And why is my machine not shutting down properly? Why is hibernate and resume so slow? And when we look at these various core scenarios, we always find that there are a few of these background processes, services or tasks or things that start up without the user directly starting them up. And they basically impose their bad behavior on the customers.
Absolutely.
And so our job in the kernel team is to look at this problem holistically from a system-wide perspective and see what we can do from the kernel, from the operating system, such that the ecosystem is benefited. So we are not looking at optimizing one service or one task, or let us try to turn this off or that off and things like that. All those measures are not going to scale well. So we want to look at the operating system as a whole and the ecosystem as a whole and see what we can do to make sure that the impact is big.
Sure.
And we have done a significant leap, in my opinion, in Windows 7. So in Windows 7, so prior to Windows 7, back in Vista, the model was similar. That is, you have a bunch of things starting up at boot. There are very few of them which are demand started, but most of them start at boot, continue running in high privilege. And Vista, there was a lot of focus on security.
Absolutely.
Whereby we did a fair amount of work in the service controller such that we allowed services to be moved from local system to less privileged accounts. So we have, for example, the service SID feature. So you now get a service specific SID in the process token if you opt in for that feature, and you can ACL your registry keys or files with that. And so in the past you used to run as local system, but now you can move away from local system.
Sure.
So even if you have vulnerability and somebody exploits you, the impact is not that high. So that's the Vista. And in Vista, what happened was that Windows is rich in features, as everybody knows. Windows has so many features, lot of features, and
The kernel has a lot of work to do.
kernel has a lot of work to do, exactly. And a lot of features are there, introduced in Windows itself out of the box. And on top of it, we have OEMs and software vendors adding features, which invariably comes with a lot of services. So in Vista, the operating system did not have enough capabilities to allow these things to be moved from always running to demand, to on-demand running. So in Vista, as I said, the focus was mostly on security. And in security, we did a lot of work such that you can move from local system to a less privileged account. But in Windows 7, the focus has shifted to performance and seeing, how we can convert these always running entities into rarely running entities, right? So in Windows 7, when we started off Windows 7, we looked at this service set and started analyzing the reasons for their always running state. And in many cases, it so happens that they didn't have a choice. For instance, let's say that the good example is a tablet input service. So that's supposed to run only on a tablet PC, but it ends up running on all the desktop machines. And everybody wonders, a user, as soon as he opens services control panel, can see tablet service installed. It's running all the time, never being used, right? And it so happened that the tablet input service depends on the presence of a tablet device. And the tablet device falls in what is called the human interface device class, the HID class, which is present in almost all the machines. But they needed some specific properties of the HID, which classify that as a tablet device in order for them to be started. So it was not a simple way of saying that, okay, if you have a HID device, you can start the service. That was not enough. So that's what I said, that if we cannot do something simple and get the bang for the buck, so we had to do something smart and kind of put it inside the OS such that the entire ecosystem can take advantage of it.
Sure.
So in the case of Windows 7, we have interesting built-in triggers, and the triggers are the following categories. So we have the most commonly used one, which is the device trigger.
Okay.
So what this does is that in the case of device trigger, you can have a service, say, express an interest in the device trigger. And when this trigger arrives, the service can say a couple of actions, either start the service or stop the service. And these triggers are rare events. Basically, they happen very few times, and in the life cycle of the machine.
Okay.
In one boot session, only when you plug in a device, you will get the device trigger. And the device trigger has got a few properties. The properties are, you have the what is called the device interface class. Go ahead. Interface class. And the device interface class is actually represented by a GUID, which is unique. And the device interface class also has other properties called what we call as hardware IDs. So a particular service can say that, okay, I am interested in device interface class called head, which is human interface device class, and the GUID, let's say the GUID is XYZ. And you have a set of hardware IDs which can be specific properties related to the device. So in other words, you can say to the service control manager when you register a service that I want to be started up or stopped. Starting and stopping are the only actions we support currently because that's the most useful.
Sure.
And moving forward, of course, we will make this extensible. But right now it's only starting and stopping. And in the case of starting and stopping, you can say, I'm interested in the hit device class, but don't start me on any hit device interface arrival. But start me on a hit interface device arrival only when a particular hardware ID is present in the device. So once we say that, we have a great filtering mechanism built into the OS, such that even if the device is very popular, like a USB is a common USB stick.
Sure.
I want to be started on a particular USB device. You plug in a device, but I don't want to be started on any such device. I want to be started only when it has specific hardware ID. And you have, do you think you can take the laptop? Can I
Sure.
show you? So if you look at this particular, how clear it is. So this is a Windows 7 beta build. And you have a service called WPD bus enum, which is the portable device enumerator service. And this service, as you can see, has got 4 triggers. So it has got a device interface arrival trigger, which is the first trigger. The second one is also a device interface arrival trigger. And the third and the fourth ones are group policy triggers. We'll get into that in a little bit of detail right now. But this service is one of the more complicated services.
Okay.
It actually starts up on 4 different conditions. The first condition is that it needs to start on a particular, this interface class GUID actually belongs to a USB device, but it doesn't want to be started on any USB device. It wants to be started only when the hardware ID matches USB store /gen disk, and that is present as part of the particular device. And the second one is actually a Bluetooth device. It wants to get started on a particular Bluetooth device arrival as well. So if your machine doesn't have Bluetooth, then this service will never start.
Which is what you want.
Which is exactly what you want. And the third one is that it also starts on group policy. And we'll talk about that right now here. So we talked about the device trigger. And the second trigger we have is a group policy trigger. So in a corporate, typical, in a corporate domain join machine, a client machine, you will have, the domain administrator applying some policies in your domain controller, and your group policy service is going to pull in that policy locally and apply it locally. And you want this service to be started up, in the case of the portable device enumerator, only on the group policy trigger. And there are 2 types of group policy triggers. One is called the machine policy, where trigger, and then you have the user policy trigger. So this service will get started, this WPD bus enum will get started on machine policy or user policy.
Okay.
The names are fairly apparent what they would do. Machine-wide policy or a policy for a per user. Per user
Sure.
basis, exactly. So this service wants to get started then. And then we also saw that the service gets started on 2 different device interface classes. For the Bluetooth, it just says any Bluetooth device, because you just have the device interface class GUID only. And for the USB, it specifically says I want to narrow it down to a hardware ID, so that it gets started on that. And we have a fair number of services in beta build in Windows 7 using these various triggers. And as I said, device trigger is used by quite a number of services.
Excellent.
And
Now, are you seeing that, so, people that are building devices
that's right.
are now have sort of the granularity in the development their drivers, I assume, or at least in their install,
That's right.
where they can say, don't just always run me. I'm
That's
going to be
right.
more intelligent. So they also have to write a little bit of code, right?
So okay. So there are a few cases. One is that if your device is published to the PNP manager, right? If it's a device which is a PNP device, then your device will also have a interface class to it,
Sure.
and it could have hardware IDs as well.
Mm-hmm.
So if your device is of that nature, then you don't have to write any code. You can use the operating system facility itself, and you can simply say, oh, I have this user mode service. You see, I have this user mode service which is used for remote management of my device. Let's take a hypothetical example.
Okay.
And if I just want to get started only when my particular device is plugged in on the PC. I don't want to get started whenever, at boot and just sit there waiting to be hacked or whatever, right?
Mm-hmm.
So let's get started only in a rare condition. In that case, you can simply use the device interface class trigger we have. So that's that case. And the second one is group policy. Now let's go to the third one. The third one is IP address trigger. Arrival and last IP address removal. So this is the first. So when the machine gets the IP address first, or when the last IP address moves away from the machine, and you would wonder why you need this.
Yes.
That's a common question. So we have a couple of scenarios for this. One is you are taking your laptop in an aeroplane, and you have no networking there, but you want to play DVD, or you want to just have a great experience with the PC without any background activity, irrelevant, interfering with you. So if you think about it, a lot of networking services are not really required for you to do your work. All you want is to play some local thing, right?
Mm-hmm.
So in that case, you can take advantage of this, and when the first IP address arrives, your service will get started. And when the last IP address leaves from the machine is out of IP, then it gets stopped. But it depends on whether you want to use this particular feature or not. I mean, some people, if they are takes a lot of time in starting your service, then it may not be worth using a trigger for it, and you may want to consider another alternative, which I will talk about now. Got a question?
Yeah, I was curious about, so if I'm in the airport, before I get on the plane, I'm in the airport and I join a wireless network. I therefore have an IP address.
That's right.
I then leave the wireless network. It just goes out of range. I don't physically disconnect. Maybe I just put my computer into sleep.
Mm-hmm.
As soon as I sit down and open it up again,
Mm-hmm.
I'll still have that IP address.
That's right.
Assigned my machine.
That's right.
And so that the network services will continue to run.
That's exactly right.
Is there a way to say, hey, when I put my machine to sleep,
Mm-hmm.
I want to flush my IP? And so in other words, that might be a little bit of a bummer, because then you'd have to reconnect again.
That's right. That's right. So that's why I said that there is for all these triggers, right, you have to use it with care like any other OS facility. I mean, you can't just blindly go and say, oh, there are triggers, let me just use them. But you are getting started and stopped hundreds of times, or, hundreds of times through the life cycle of the machine. It may not be worth it, right?
Certainly.
So it has to be kind of balanced with benefits. And in Windows, we analyze the various inbox services, and then made sure that they are not going to start and stop all the time, but only under those rare conditions.
Yeah.
So now the third one. And the fourth one is another interesting one. It's called the domain join trigger. And then corresponding one is domain leave. So if you are a service which its functionality is only needed in a domain, and a good example in Windows is the Windows time service. And the Windows time service, what it does is, in a domain join machine, it synchronizes your local clock with the DC clock, so that the Kerberos communications can work properly. Kerberos has a strict time limit between the client and the server. The time difference should not be beyond a certain limit. So this Win32 time service, or the Windows time service, makes sure that the clocks are synchronized properly. And its functionality is mostly meant for a domain join machine. And so it takes advantage of this trigger. So when you do the domain join, which is, in a home PC you will never do it. and in a corporate machine you will join the machine to the domain. At that time the service will get, you could do either of them, so the way the triggers work is that you have a set of triggers,
Yeah.
T1, T2, T3, etc., Tn, and you have a set of actions, A1, A2, etc., AM. And this action, as I said, and the triggers, we are discussing the various triggers right now. The actions that we support today are start and stop. And you can pretty much have any kind of mix and match. You can say, when T1 arrives, I want to take action A1. When T2 arrives, I want to take action A2. And when Tn arrives, I want to take action A3 and so on. So these are kind of independent entities. You can mix and match the way you want them to. And we have the service controller API, change service config too. You can use to set all these things up, and we'll have MSD and samples and things like that.
Excellent.
And so you have the fourth trigger, which is called the domain join trigger. So as I said, it's fairly useful if you are only going to run in a corporate, in a domain environment. And so we also thought about the case where, what if, this was related to the question you asked earlier, do I have to write some code? Yes, you have to write some code if it does not fit in this particular classes of things that we are talking about. So fifth one, what we have is what is called a custom trigger. So in the case of custom trigger, you can pretty much be a trigger generator yourself. Good example is, you have a driver, and the driver wants to start. Driver has got a user mode service counterpart, and the driver wants to start the user mode service counterpart only in certain conditions. Let's say that it wants to take some failure. I'm just giving a hypothetical example.
Sure.
It wants to take some action on a failure and report to the administrator and things like that. So what it will do is, it will basically write a custom ETW event, and you have the event write API. This is a public API. And using this API, you can generate an ETW event with a particular GUID and with whatever payload you want. And the payload that you generate can either be strings, or it can be binary blob of data. And what you need to say is that the user mode service registration, the trigger registration with the service control manager, has to contain this ETW event GUID and the particular payload that you expect. So that is exactly how the device interface stuff works. That is, you have the particular GUID and you have the hardware ID strings, which are generated by the PNP manager in this particular case. So in the case of custom ETW event, if you are a driver, you could write a particular ETW event with whatever GUID you set, and with whatever payload you want to add. And based on that, you can say, oh, when I just have one ETW event provider, which is my driver, I write that. For this particular payload, I want to start service X. For this different payload, I want to start service Y. I mean, just if you want to be that fancy and do stuff like that.
But that's great that we're enabling that.
Yes, we are enabling that, and all of this required a fair amount of plumbing inside the operating system in various components. It's not just the service controller or the kernel. It's various components like LSA and plug and play, and then you have the group policy, and you have the networking stack. So we plumbed various parts to make this, and that's why I said that we cannot do something simple. I mean, we know what the problem is, but in order to solve holistically, we have to actually have a release like Windows 7, where we try to really make, do the heavy lifting, and try to make the ecosystem, basically, change the game, such that, moving forward, people always think trigger first before they think auto or anything else, right?
Yes.
So they don't want to do auto. We just want to do trigger right away. And then if the trigger, for whatever reason, is not worth it, as a good example is, you are starting and stopping all the time. Maybe a good example where trigger may not be worth it. If that is not the case, which is 90% of the services, then you can fit into one of these buckets. If none of the first four fit in, you can go to the fifth bucket and fit in the custom, create your own. Exactly.
Excellent. So I mean, the net from this clearly is that, at least one of them is that Windows 7 boots faster because of this. I mean,
That's
at least it launches into a user session faster. And it also leaves a user session faster.
Right.
Because it's not waiting. So I remember one of the things from Vista that I remember, at least in the pre-SP1 days, was the really long shutdown sequence.
Right.
And I would imagine part of that is because you were waiting for services to stop or
That's
to
right.
finish their work
That's right.
before they can stop, and then you can
Absolutely.
say. So now what we're going to see is that you've actually sped up, startup, shutdown
That's right.
directly because of this work.
Absolutely. So,
Excellent.
one second. So, as I said, by touching the background processes, looking at the background process space holistically, and making such system-wide changes, we improve so many scenarios we don't even really think about. For example, security is improved. You would ask, how can security be improved, right? So imagine that you have a PC in which a particular device, like tablet device, is never going to be there because it's my desktop PC. And if whatever vulnerabilities on your tablet is the cause of your takeover of your machine, you have completely removed that vector. So the whole goal is that you run code only when necessary, and you run code in less privileged mode. Don't run in high privilege, and run code as less as possible. That's the moral of the story. I mean, don't keep running your code all the time,
Yes.
because no matter how smart you are and how perfect you are, you can make a little mistake, cause a buffer overrun, whatever, and then your
Then you cause problems.
entire PC is taken over, and in a domain, the
Yeah.
domain can be taken over, right? The entire domain can be infected. So it has got so many side benefits of moving to this model whereby you don't always run things all the time, right? So that's the Windows 7 trigger situation where we have spent significant efforts.
Great job.
Yeah.
And I think Windows 7, they're sort of marketing it as a consumer release, consumer focus, and I think that's the right thing to do in the sense that these are the sort of the real reasons behind why they can say that, right?
That's right.
So rather have background processes which users never interact with anyway,
That's right.
sucking up my experience. In other words, slowing the machine down, taking it longer for me to move windows around.
Right.
You're removing that
Right.
by having a sort of intelligent trigger-based service model,
That's right.
which is, I think, smart. And of course, a lot of the brain salad surgery of Windows happens in kernel world.
That's right.
So we always love putting you guys on camera.
Right, all right.
I mean, you're the core of the OS, right?
Yeah.
Everything goes through the kernel.
That's right. So I also want to talk about something slightly different, relevant to background processing, but not directly relevant to the
To the
services,
trigger.
to the triggers, and that is the Windows tasks. So what we have done in Windows 7 is that we also looked at background processes holistically. I mean, it's not enough to just say that, okay, let's fix the services, but let the tasks go whatever, right? I mean, you can't do that. We have to look at the entire landscape holistically. So we have in Windows 7, I think I can erase
Yeah,
this.
sure,
Probably
we got that on
captured all
phone.
that. So in Windows 7, we have this. This is not really, something that developers or people would see, but I just wanted to explain is that we have what is called this unified background process manager. Background process manager, UBPM, which is we want to, this is like the single point of control for both services and tasks. So besides the trigger work, we also have done this sort of process lifecycle unification. So you have the SCM here, which is the services.exe, and we have the task scheduler, which is the schedule service. And both of them are using this particular component for activation. So if you look at the task list, T-list, minus T, or you look at the parent-child relationship in Task Manager, you can now see that both services and tasks are the child of what we call as the UBPM. This, in fact, is also services.exe, because we didn't want to introduce a new process for this. We are all about reducing number of processes, and we don't want to create newer and newer processes. So we already have an existing process called services.exe. So you can see two sets of children. One is what is called the tasks, Windows tasks, and one is called the Windows services, which we have been talking about so far. And tasks, you can, this one, people are all familiar with Windows services. Good example is svc host.exe, which is the shared service host, which hosts many services within it. And shared service host runs in various accounts. And each account has got so many different services within it. And for tasks, we have an equivalent called task host.exe. This again is a Windows 7 innovation. Task host.exe. So when we look at this, at the core, what this engine is doing is process lifecycle management. In other words, starting on triggers, stopping on triggers, taking recovery actions, doing a dependency model, and things like that, which are all relevant to process lifecycle activation. It's kind of disjoint from the programming model directly. The tasks are written with a different programming model. They can be a plain old exe like calculator, where a service has to follow a specific programming model. But the programming model is independent of the way you manage them. So all those management stuff has kind of come into this UBPM, where we basically have a UBPM, and it controls both Windows Service and Windows Tasks. The advantage is that any innovations we make to the UBPM, the benefits are felt by not just by services, but also by tasks. For example, tasks in Vista itself supported a set of triggers.
Okay.
So in Vista, you can start a task on boot, start a task on user logon, start a task on Crimson event, on the event log event, and things like that. And services, as you know, in Vista did not support any such triggers. And the entire trigger stuff was implemented in task scheduler service. It was completely a different service, which is an svc host service. So it doesn't make sense for, as a Windows operating system, to re-implement the same thing in multiple components.
Absolutely.
It doesn't make any engineering sense or any sort of sense. So, but there are a lot of challenges, mainly with application compatibility and things like that. But we believe at this stage, we are fairly solid there. We have handled all the necessary
So you just
issues.
have sort of proxy stubs that you left so it wouldn't break other things.
That's right.
Forwards the
That's
message.
right. So in other words, if you want to get into this particular UBPM, you need to actually opt in, sort of thing.
Okay.
And for Windows 7, we are only having inbox components opt into this model because we didn't want to take application compatibility here in Windows 7.
Absolutely.
And that's a big concern for us.
Sure.
But this is the kind of direction. I just want to make sure that people understand that moving forward, our investments will be such that we want to affect the background process space as a whole. So if we invest in one trigger, both services and tasks can take advantage of it, the core of it, except that the APIs have to expose it, and so on. And another important thing I want to also convey here is that what we found, from looking at various services and tasks is that people tend to gravitate to either services or tasks based on their familiarity. So if they have done a service sometime in their life and they have a problem to solve, they would first think, let's solve it as a service, right? And similarly with the tasks, that is, if you have written a task, you have written a bad job in the past, and you have a new problem you want to solve with a bad job, you will immediately gravitate towards a task.
Sure.
And we suggest, even internally, and we suggest to our customers, is that we don't want to think that way. We want to think what is the best background process for the job. That is, if you have a background process that runs very rarely and that wants to run on a schedule, right, once a week, or I want to do a backup, once in 15 days, whatever, right? So tasks which are things which are kind of rare and are not frequent, or in that case, you may want to think of using tasks.
Yes.
And and the tasks, the good thing about tasks is that the tasks have been integrated well with various system metrics. For instance, one good thing is that you can specifically say that a particular task you don't want to run on if the machine is on battery. So don't run on a laptop, right? Don't run on battery. So this task will not run if your machine switches to battery power. And that means that your task should be something like, okay, it's okay to do this, but it's okay to do it later also. Like I want to defrag my disk. It's not that super critical, but it's a maintenance sort of work. And you can put that as a task. And tasks have capabilities that very similar to services, except the programming model is different, where tasks are very loose. They are pretty much can be any old exe, or you can write a COM task. And MSDN has got the guidelines of writing that. And in the case of tasks, you can pretty much have a kind of like a free-form programming model, and you can also fit in with various constraints that you can supply as part of the task registration, saying don't run me on battery, run only a single instance, don't run multiple instances, run only on an idle, which is very important. That is, if do not disturb the user, please. That's what that setting means. That is, when the machine is idle, and we will calculate what idle means. It's mostly driven on user input. The user is actively working on the machine, we will not start the task. But if the user just left the machine, went for lunch, we will run the task, and then the task can do whatever background activities it can. So it's not really disturbing the user. So if you have such conditions whereby you want to run rarely, you want to do some maintenance jobs, you don't have too many worries about starting up at boot or at a specific spot. The service model is very powerful. It can pretty much do whatever you want. And if you want to start up at a specific spot in boot, you have a bunch of dependencies you want to express and things like that, you may want to use this. And for tasks, we may want to use the we want to use for very kind of simple kind of things. And so that's the kind of split I want to also convey here, that people should think about their scenario before they go ahead and write a service or a task. Because once you stick this into the operating system, as a package the user installs, or as part of the OS, whatever it is, the cost that the user pays if something goes wrong is very, very high. And we need to be very mindful of that. And in the past, it has been that, the mindset has been that, okay, if I write a driver, I'll be super careful, because I'll bug check the machine with a blue screen and things like that.
Yeah.
And what people are realizing is that, user mode services or user mode components running in high privilege have very similar sort of problems. If you are not careful there, do a sloppy job there, you can end up costing a lot of productivity, a lot of money and things like that. So anything that you introduce into the OS be top notch. So that's the kind of message also we try to strive around here. Try our best to do this, and also try to make OS wide changes such that the entire operating system ecosystem is benefited.
Now, but is there anything inside of the OS that sort of monitors whether or not clearly, as you were saying, I mean, if you write a service, a good reason to use a service is a long-running task.
That's right.
You'd want it to be a service, probably.
That's right.
But I guess what I'm asking you, is there no way, some sort of kind of safety system that could say, wow, that service has been running too long, it's eating up too much memory, it's using too much processor, I'm going to kill it. Do you have that sort of automatic checking inside of the OS to protect against, it's a super hard problem, because it might actually be that the service is doing some important computation.
That's right. So far we don't have such a, so in Windows, first thing we always think about whenever we have any great idea here is that, can that fly in the real world? In other words, once we make this part of the product, will it stick, right?
Sure.
So we have to be super careful, and also we use a lot of historical information here, which is what worked in the past. I mean, there are a lot of things that did not work, but there are a lot of things that worked in Windows. That's why Windows is a successful product. And what worked in the past, and we learn from those lessons, right? So the one that you're suggesting, sounds good, and we will try to see what we can do in the self-healing. Again, if you want to do such a project, we would be looking at it holistically. We won't do it for a specific feature or a specific particular problem that you have a runaway process. We would have abilities to diagnose it. For instance, for example, in Vista itself, we added this feature called service tagging, which is not very intrusive or anything. All it does is that if you have a SVC host process in which one particular thread in that process is running away, chewing CPU, for instance. Then we can kind of identify that. So we basically have a feature called service tag, which is attached to a particular service inside a SVC host process and the threads it spawns.
Great.
So if you create a thread and that thread is running, we'll identify that back to the root cause. And the performance tools will go and catch such things. So those are like things that are not so brute, not very yes or no kind of thing that will help the users, but are not going to terminate and things like that. Because once we get into that space, we have to be super careful.
Agreed.
That's why we don't have such features. But we have been hearing feedback to have sort of self-healing sort of models. But again, we have to think about it, like the way we thought about triggers. How can we do a kind of like a OS-wide, a good job there, so that people can really take advantage of it, but not have a lot of problems caused by it.
Yeah.
So,
I mean, it's easy to throw out ideas, but like you're saying, in reality, I mean, come on, it's a general purpose operating system,
Absolutely,
which by definition means it has to support umpteen scenarios, many of which you don't even expect.
Absolutely.
So
many of which we don't even expect. So we tread this path very carefully, and always, anything we do has to be like explicitly opted in by the users and has to be tested extremely well.
Excellent.
Before it becomes part of the product, and things like that. So the other one is that we also have, I think we can, probably I can send you a link later, is that we have a paper which covers all of this. It's a white paper.
Perfect.
Which has been recently published.
We'll post it on this video.
Yeah, if we could do that, then that will give them an overall idea about what I've been talking about here.
Sure, but now they get to see you, right?
Yeah.
It's often the kernel people. I mean, do they come out at night? Where are they all? So they're real. They're humans, just like you.
We are real. That's right. Yeah.
So I mean, it's a very cool. I mean, the Windows kernel has always been fascinating to me because of the amount of work it has to do and the amount of insanity it has to support.
That's right.
A lot of which happens in user mode.
That's right.
And I know that what the engineering team for Windows 7 has been doing, spending a lot of time. It's actually started in Vista. Was you guys mapped out all these huge dependency trees to figure out, what's doing what, what depends on the other thing. Also, probably doing redundancy trees, because you just mentioned in the schedule service, you had a redundant behavior.
That's right.
But now you moved into a sort of a unified context.
This is all, the schedule service implementation. Again, we were very careful not to borrow code or anything like that, because after all, we are all Windows here. And we can write code. So we had a brand new plan in mind, and the schedule service supports application compatibility, so that if you are a guy who does not opt in and things like that, which is in the case of Windows 7 for most outside tasks, they will all be managed by the schedule service.
Okay.
So that remains, because that's the best way to support application compatibility. You just keep the old code exactly like that.
Sure.
Because we know that even 1 or 2 line changes cause trouble, and then this is a brand new sort of wholly newly developed for Windows 7.
Excellent.
That's the way we, and then moving forward, we want to affect background processes as a whole, and any feature we put in for background processes, people can just take advantage of it.
Excellent. Well, hey, it's been great talking to you.
Great.
Thanks for taking time out of your busy schedule.
No problem.
You're writing code and you're working on a fantastic. I have to say, I'll be saying this to everybody. Windows 7 is the best version of Windows yet, in my opinion.
Excellent.
I've been using it since Alpha.
Excellent.
And it just blazes, man. And I know a lot of it has to do with the work you guys have done down in the core. So, nice work, man.
Great. Thank you, man.
Great to meet you.
Thank you very much. Yeah.
Take care.
Cool.